Welcome everyone, and thank you for joining our first project highlight, our Haystack Community Project Highlight. And before anything else, really a big thank you to Stefano for being the first person to take up this challenge. I will give a quick intro into what this type of presentation is. So the idea is we want to learn more about what people within the Haystack community build with Haystack. And this is the first edition. Just as a quick heads up, we will have some time for Q&A at the end. If you do have any questions during the presentation, please don't hesitate to use the Q&A functionality, because at the end of it, I'll go through those questions and ask some to Stefano live. But we'll also try something new. So if you would rather ask your question in person live, at the end of the presentation, raise your hand and I'll do my best to get to everyone, unmute you so you can ask your question, and then hopefully we can get through everyone who raises their hands. Finally, as I mentioned, this is the first this type of presentation that we're doing. So once the webinar is over, there should hopefully be a screen in your browser that has two very simple questions, and this is a way for us to see if you'd like to see more of these and see if there's anyone else who would be willing to do such a presentation. And without further ado, Stefano, I'm going to mute myself and turn my camera off, and I leave the stage to you.
Thank you very much, Tuana. I'm really happy and excited to share this to you today. And so I start with this project highlight about fact-checking rocks, how to build a fact-checking application using Haystack. I am Stefano Fiorucci, an Italian machine learning engineer. I love natural language processing. And during the last year, I got passionate about semantic, neural, and vector search. In this infodemic era, fact-checking is becoming a vital task. However, it is complex and time-consuming activity, but artificial intelligence and natural language processing tools can come to our aid. And with this in mind, I developed this little project. It is a simple fact-checking system about rock music, where the user enters a factual statement, and our system tries to understand if the knowledge base confirms, contradicts, or is neutral about that statement. I use the knowledge contained in Wikipedia. I use the modern NLP tools, and with zero manual effort for annotation. The final outcome of my project is a Streamlit web app, which is hosted on Hugging Face Spaces. And it is powered by the great Haystack framework. This is the agenda of this talk. First, we'll start with Haystack basics, because fact-checking rocks is built upon Haystack. Then I go deeper in the fact-checking rocks project idea. And so I'll show you the implementation and how to implement a custom node in Haystack. So let's start. Most of you already know Haystack. For those who don't, it is an open source NLP framework. Using Haystack, you can build end-to-end search systems. And it covers several use cases, including question answering, document retrieval, image retrieval. It is modular, so it combines several open source technologies, and you have multiple choices to fit your tech stack and use case. You can pick your favorite file converter, database, machine learning model. And the systems that you build using Haystack are production ready. so they can easily scale to millions of documents. And Haystack also provides a REST API, and it is very customizable. So, and also developer friendly. And as we will see later, you can easily add nodes. But let's try to understand the main concept in the Haystack framework. First, the document stores. A document store is simply a database that stores your documents, which can be text or images, and also stores metadata and representation such as vectors. In Haystack, you can use a SQL database, enterprise search platforms such as Elasticsearch or OpenSearch, and also modern database, vector databases, such as Web8 and Milvus. In Haystack, the nodes are the blocks that process and route incoming text, and using them, you can perform pre-processing, retrieving, and a great variety of NLP tasks, such as classification, entity extraction, summarization, and so on. And using nodes, you can create pipelines. They are directed acyclic graphs when you perform several types of processing using the nodes. And typically, pipelines can be defined for indexing or querying purposes. Next, I show you the Haystack architecture for the question answering use case. On the left, you see the indexing pipeline where your files enter, they are converted into documents and then written to the document store. And on the right, there is the search pipeline. So the user enters a question, then the retriever returns the documents that are more relevant to that question. And then another node, which can be a reader or a generator, tries to extract or generate an answer. And the idea is that while the reader is usually a transformer model that do close analysis of the text, and so it can be slow when running on a large document collection, the retriever is really fast, and so it can provide only the relevant documents, and from the combination of these two nodes comes the power of this system. I talked to you about this architecture because it is similar to that of my project. But now let's go to the idea of fact-checking rocks. Here we have the indexing phase where data are crawled from Wikipedia, then they are pre-processed and encoded using a language model, so converted into vectors, and then textual passages and vectors are stored in a document store. During the querying phase, the user enters a statement, a factual statement to check. Then, using the embedding retriever, the relevant passages are retrieved from the document store, and then through this new entailment checker node, the system computes the textual entailment between each relevant passage and the user statement using a natural language inference model. Then these entailment scores are aggregated, and so a summary score is produced, and we can understand if there is entailment, neutral, or contradiction between the user statement and the relevant passages. Now I try to explain a bit better the main components of these systems, starting from the embedding retriever. Typically, a retriever sweeps through a document store and returns a set of candidate documents that are relevant to the query. In embedding retrieval, we use a transformer model to encode documents and query. And particularly, we use the sentence transformer language models. And these language models are trained such that they learn to embed similar sentences near to each other in a shared embedding space. But what does it happen in short words? In the indexing phase, the documents are encoded as vectors and saved in the document store. We can see here 3 examples of documents, textual passages, two speaking about Green Day, and 1 speaking about Jeff Buckley and Hallelujah cover. Then at query time, the statement to check is encoded as a vector, and this is the statement. Then the nearest document and passages are retrieved by similarity. So if my statement is about Green Day being a punk rock band, the nearest documents are just these 2 documents speaking about Green Day. Now, let's understand the core of the Entailment Checker node, so natural language inference model. In NLP, natural language inference is the task of determining whether an hypothesis is true, false, or undetermined, given a premise. And here we see a sample of a natural language inference dataset. So there is a premise, an hypothesis, and a label, which can be contradiction, neutral, or entailment. So once a model of this type is trained, you can pass a premise, an hypothesis, and get a label or probabilities of entailment, neutral, or contradiction. In practice, we rarely see natural language inference model used for their original task, but instead they are very used for zero-shot classification task. For example, if I want to understand if a specific sentence speaks about sports, I can pass the sentence as a premise. And as an hypothesis, the sentence, this example is about sports. And then I get a label. And so I understand if the sentence is about sports. So I make the classification. But in our case, we are going to use these models for their original task. So for natural language inference. In the what does it happen in this new node called Entailment Checker? First, we compute the textual entailment between each text passage as a premise and the user statement as an hypothesis using a natural language inference model. And for every text passage, we have 3 scores, sum into 1, about entailment, contradiction, and neutral. Then we aggregate the textual entailment scores. So we compute the weighted average of them, where the weight is the relevance scores given by the retriever. The relevance scores indicates how similar a textual passage is to the statement to check. Then I also made an empirical consideration. If in the first n passages, where n is less than key, there is a strong evidence of entailment or contradiction, it is better not to consider the less relevant documents. They would add noise, and ignoring them, we can also be faster. So this is the idea of this new node. But now let's go to the implementation in Haystack of this simple system. We start with loading and preprocessing data. We have already crawled from Wikipedia the data about rock music, and for every page, now we have a JSON with page content, title, and URL. If you want to understand more about the crawling part, you can find the code on GitHub or Hugging Face Spaces. But there we are loading these JSONs from disk, and we are creating a list of documents. Then we preprocess these documents, splitting them by chunks of 2 sentences. And then we select only the documents with at least 10 words. Otherwise, they are not very informative. The second step is about encoding and writing documents in the document store. So we initialize a document store, a files document store. So it is based on the meta research files library. It is a library for storing and efficiently retrieving vectors. And so we initialize this document store, then we write the textual documents in the document store. Then we also initialize the retriever. Particularly, it is based on this sentence transformer model, a sentence transformer model which is tailored for semantic search. And by the embed meta fields attribute, we are deciding to embed also the name that contains the Wikipedia page title because it is informative. By calling the update embeddings method, we are generating the embeddings, the vectors corresponding to the textual passages, and also storing them in the document store. So now we have already done the indexing phase, and we also defined the embedding retriever. So we have to define, to implement this new type of node, the Entailment Checker node. But how can we implement a custom node for Haystack? In the Haystack documentation, there is a good guide. And so you can create custom nodes to perform various tasks. We start with creating a new class that inherits from base component. Then we have to set outgoing edges as a class attribute. Most nodes have one outgoing edge, while decision nodes have more than one outgoing edge. And in those cases, you have to define an internal method called calculate outgoing edges. Then you have to define a run method that is executed when the pipeline calls your node. And the input arguments of this run method should consist of all configuration parameters that you want to allow, and also the data arguments that you expect as input from a previous node. For example, data parameters can be documents, query, file paths, and so on. The run method should return a tuple. The first element of this tuple is an output dictionary of the data that you want to return and pass to the next node, while the second element is the name, is a string containing the name of the outgoing edge. Last, you have to define a run batch method that makes it possible for query pipelines to accept more than one query as input. And it is similar to the run method. But now let's go to the real implementation of the Entailment Checker node. First, I defined an init method, so a constructor, and in this init method, I'm setting the node's attributes to be used later. And particularly, we are loading a natural language inference model and a tokenizer from Hugging Face transformers. Then, through devices, we are giving to the user the possibility to use CPU or GPU. And in this constructor method, we also set the entailment contradiction threshold that we will see later. Then we define this get entailment method where the core natural language processing inference happens. It takes as input a string with the premise and a string with an hypothesis. We set PyTorch to inference mode because at inference we don't want the gradients to be computed. Then we defined the input for the natural language inference model that is given by the premise, the separator, and the hypothesis, and we tokenize this string. Then we put this input to the first device, which can be CPU or GPU. Then we make a forward pass of our model, and we get some output, and this output contains the logits, so the unnormalized probabilities. But we want normalized probabilities sum into one. So we have to introduce a softmax function, and so we compute these probabilities, and then we put them back to CPU, and we convert them from a PyTorch tensor to a NumPy array. The return value of this method is a dictionary that contains as keys the labels, so entailment, contradiction, and neutral, and as values the probabilities. And I made an example of this, the use of this method. And so if we pass as a premise, I have a blue-eyed cat, and as an hypothesis, my cat has yellow eyes, we get back a dictionary that contains all this information, and we have a probability of contradiction of 0.99. Yeah. Then we have to define the run method, and there we have a for loop, and for every textual passage returned by the retriever, we get the entailment, and then we aggregate these entailment scores, and we use as a weight the relevance score, which is doc.score. We are also applying there the empirical consideration. So if in the first documents there is a strong evidence of entailment or contradiction, we break the for loop and we don't consider the rest less relevant documents. So what does this run method return? It returns a tuple, but the dictionary of this tuple contains the used documents, so only the documents that are used for the natural language inference task, and the aggregate entailment info. So a dictionary contained some summary score about contradiction, neutral, and entailment. Now we can define a pipeline, a fact-checking pipeline using this new node. So first we initialize this new node using a good natural language inference model. And we also set the entailment contradiction threshold to 0.5. Then we define a new pipeline, and we add two nodes to this pipeline: the retriever, which we already defined, and then this entailment checker. And now we can use this path checking pipeline. And for example, we pass to this pipeline the statement. This means have had any influence on other bands. And we also specify for the retriever to return the top 5 textual passages. And as a result, we get some documents that have been used for natural language inference, each one with its relevance score and other information, but also the aggregate entailment information. So in this case, we get a 0 probability of contradiction and some high values for neutral and entailment. So probably our statement is true. But now let's try to see our application in action if in again phase spaces, hoping that it works. Moment. Yeah. Are you seeing my browser? I hope so. Yeah. Okay. So we run this statement. Elvis Presley is alive. Yeah, the knowledge base seemed to contradict our statement. And so we get also the entailment contradiction in neutral scores. We have a triangle plot showing that there is a strong signal of contradiction. We get also the most relevant snippets. In this case, the used snippet is 1 because it contains a strong signal of contradiction. And in these last days, I developed a bonus feature using a large language model, thanks to the Haystack framework and the new prompt node, and using a large language model with the right prompt, we try to explain why there is contradiction. Elvis Presley died on 1977. So the final answer is no. And it seems to work well. Yeah. Let's try some other more difficult questions. Statement to be verified. The Beach Boys were involved with the Manson family. In this case, there is entailment, but it is interesting because in this case, 4 different textual passages have been used. And so it combines the information from these different passages. And here probably the language model, yeah, doesn't do a really good job, but yeah, it is somewhat okay. Let's try with the last statement. King Crimson played progressive rock. Yeah, the knowledge base confirms our statement. It is interesting because the snippet used in this case is from the tool band Wikipedia page and not about King Crimson. And we get an explanation that King Crimson are progressive rock pioneers and tool have always expressed the massive impact that progressive rock pioneers have had on their music. Therefore, the final answer is yes. Yeah, it seems good. Let's go back to the presentation. Yeah, I draw some little conclusions. My approach, yeah, is simple and a bit naive and has some structural limits. First, there is no statement detection. In fact, the statement to be verified is chosen by the user, while in real-world application, this step is often necessary if I want, for example, to check the statement from a newspaper article. Second, Wikipedia is taken as a source of truth. Unfortunately, it does not contain universal knowledge, and there is no guarantee that it is a source of truth. Nowadays, there are certainly very interesting approaches that view a snapshot of the entire web as an uncurated source of knowledge. For example, Meta Research recently published a paper about this topic, introducing the sphere corpus. Several papers and even my experiment show a general effectiveness of dense retrieval in providing textual passages for evaluating the user statement. However, there might be cases in which the most similar textual passages don't provide useful information for fact-checking purposes. For example, if I enter the statement, the Beatles were influenced by Bono Vox, I get back some textual passages about the Beatles, some about Bono Vox and U2, but none of these passages contain the information that it is needed to say that the statement is false. So yeah, there are probably more interesting approaches to face problems of this type. No organic evaluation was performed, but only manual experiments. While being simple, we can make with very low effort some improvements to these systems. For reasons of simplicity and infrastructural limitation, the retrieval uses only a very small portion of the Wikipedia data. And so with these few data available, in many cases, the knowledge base remains neutral, even with respect to statements about rock albums and songs. Certainly, fact-checking quality could improve by expanding the knowledge base and possibly extending it to the entire Wikipedia. Another interesting aspect is both the retriever model and the natural language inference model are general purpose and have not been fine-tuned for our domain. So if fine-tuned, they can show probably better performances. But the retriever model might be adapted with low effort using generative pseudo-labeling. It is included in the Haystack framework and doesn't require manual annotation. So it is surely an interesting approach to explore. I want to give you a last word about building modern NLP applications in real world. Nowadays, language models and large language models have strong text comprehension and generation abilities. But their knowledge is generic and not easily updated over time. Their knowledge is not domain specific. So if you want to start, we can think of combining them with retrieval systems. So the retrieval system provides the knowledge while the language model provides the reasoning. And so it can be, I think, a good point to start with a new language application. I hope that the presentation has been good, and I want to thank you. And there I give you some links about this application on Hugging Face Spaces and GitHub. Thank you.
Thank you, Stefano. That was really nice. I think Bidya just shared the link to the Hugging Face Spaces, potentially GitHub as well, so you can find that in the chat. And we have a few questions that I'm going to read out to you, but first I'll get the ones that are more admin out of the way. So there were a couple of questions about whether this session is being recorded and whether you can find the slides later on. It is being recorded, so if all goes well, hopefully this will be up on our YouTube channel, and we'll also include a link. So we started a monthly newsletter that you can sign up for if you want, so the link will be there. If not, you can find it on the DeepSet YouTube account, hopefully next week, if all goes well. And I don't see why we wouldn't provide the slides as well, so hopefully those will be there soon too. Okay, so now that's out of the way, I'm going to read out some questions to you, Stefano. So one question was, what was the motivation for chunking into 2 sentences? What difference did you see compared to splitting by words?
Yeah, I think that it is a common question also, I think, in the Haystack community, and probably there is not a unique answer for this question. Probably it depends on your task, and you have to try several splitting strategies. In my case, I started from the fact that, yeah, I want the information to be divided by sentences, so I don't want a fixed number of words. If I want a fixed number of words, I want, in any case, to respect the sentence boundaries. But I think that, yeah, this part is experimental. So in every use case, you have to experiment and find what is the optimal length. If you want to add something to Anna, please feel free. Yeah.
Trial and error, I suppose. But yeah. All right, so there is another question. And I think the answer came just after the question was posted, but I will ask it anyway. Is there a way to see the passage from where it deduced the answer, contradiction, entailment, or neutrality?
Yeah, in my experience, using natural language inference model out of the box, it is not particularly possible or easy to have this information, but I found that this large language model, including the one that I used, Google Fluency 5 Large, is good at detecting what is the most important part to give the signal of entailment, contradiction, or neutral. Particularly, I'm passing to the large language model a prompt given by, as a premise, all the information in the used textual passages, and as an hypothesis, the user statement, and I ask the large language model to specify why there is entailment or there is contradiction between the two, and it often detects and gives me as a motivation the right part of the original passages. Yeah.
Okay. So as far as I understood, you said that when it's a contradiction, this is a bit more difficult to do, though, right?
Yeah, I don't know. I don't remember to have. No, it is
fine.
No, okay.
Yeah, okay. Now I see what you mean. The next question, this person had a few questions, so hold on, let me find one. What large language model did you use for the why question? What about documents in other languages, for example?
Yeah. In this case, for the why, as I said, I used the Google Flantify model that I found it really good because it is trained in a great variety of NLP tasks along with prompt and instructions. So in short words, it learns to do a bit of reasoning about your prompt and your instructions. And so I used it, but you can use, I think, you can try also other types, also closed source models. Yeah. And about other languages, I didn't try. And if there is someone that can speak about this type of models, can give the answer. I read something about them, also about Google Flantify, but I didn't experiment. So yeah, if there is someone that can give a better explanation, please go.
Yeah, I think there was a question specifically about Italian, but I don't see it anymore. Yeah, I think the question has been answered in writing. There's another question from the same person, which I'm actually quite interested in, and I think you somewhat delved into it in the limitations part. How can we proceed with out-of-domain documents, for example, financial legal documents? Do you believe these models will behave well on custom documents?
Yeah, about the retrieval part, you can try to adapt these sentence transformers for semantic search using, for example, the GPL tool. Yeah, and also you can read also the paper by Niels Reimers. But in any case, if you think about language model, you can think of the original language model. I don't know about trained on a specific language. Then usually there are also domain adapted models. So if your domain is specific, so legal, scientific, yeah. In my case, for the rock music, it's not so different from English normal written text, but if your domain is very specific, it may be useful to search for a domain adapted language model, I think. Yeah.
I have an addition to that question alongside one of the last questions we got. So the question we got, so this is not from me, was would the response have been better with prompt node if you had passed it through the entailment node once again? And then on top of that, so I think I understand what this person is trying to ask at least. If not, Marco, feel free to raise your hand later and you can ask it in person. So we just talked about out-of-domain documents. What about out-of-domain questions? And do you think you can explain why there is no proper answer with the next prompt node step? So if we are now in the rock music category and there's no documents around anything about finance, if I were to ask a question about that, how would you see it behaving?
Yeah, please, can you explain the question a bit? Yeah.
How do you think we could account for out-of-domain questions for a fact-checking application? So this is not about out-of-domain documents being added, but here the whole fact-checking application is able to give me give me this contradicts or is accurate about statements about rock music. Do you think there's a way we could maybe be able to consume out-of-domain questions with the use of the prompt node at the end?
Yeah, I think that in the current application, if you enter an out-of-domain statement, probably, yeah, the knowledge base is neutral. So you don't get entailment or contradiction. Using a large language models, it can be different because, yeah, the large language models have some knowledge of the word. So in my application, I conditioned the large language model to use my information to give an answer, to explain something. But you can also use it for its knowledge of the word. So sometimes you can also answer out of domain questions. But in my case, being in fact checking, I would like more to condition what the language model use to do its explanation. Furthermore, this large language model is a recent addition, but yeah, using these systems and using interface space, the large language model is still a bit slow. And so, yeah, I prefer to use, for the moment, to use a model that is trained on natural language inference, but probably I can also, in the future, replace all the application using only a large language model. Yeah.
Okay. We have a bit over 10 minutes left still, and so this person had to leave, so I'm going to repeat the question so that they can re-listen to it when we have the recording. It's a bit long, so bear with me. Have you explored other embedding methods for the fact checker, i.e. text embeddings via OpenAI, as in if there is an extra computational cost or if the performance increase is worth it, etc.? I wonder if there's a benchmark for entailment or Q&A, etc., or if it's even possible to do that with GPT via Haystack.
Yeah, I've explored. I'm reading a bit because it is longer.
My understanding is whether you've tried the OpenAI API to use the retriever models.
No, I didn't try it, but talking about retrieval, now I'm also thinking about using also Cohere embeddings, if you want. And about Cohere embeddings, they recently, I think, released some great multilingual embeddings. So you can represent text of several languages in the same space. So I think that it is possible. I didn't experiment it, but you can also say about Haystack that during, I think, the last days, there is some new invocation layer involved. So in the future, it will be easier and easier use a model from the Hugging Face transformers, or do the same thing using a model from OpenAI, from Cohere, in a transparent way, I think.
Nice. And I have two final questions. And then I think we only have about just over 5 minutes left anyway. Someone really likes diagrams and is asking which tool you use. I think it's probably the same one we use, and I don't remember the name.
Excalibur, you suggested it
yes.
to me in the past.
Maybe we can add the, I think Julian might be writing the link in the Q&A. So Ashish, you'll get a link for the tool. This is probably going to be you explaining how you're using the prompt node with LLMs, but what method are you using to explain the rationale behind the answer?
Yeah, I think that it is, I give to the prompt model, to the large language model, a prompt with the premise, the hypothesis, and then a prompt such as, please explain me why the premise contradicts or entails the hypothesis, reasoning step by step, then explanation. A prompt like this, but you can, probably it's not the best prompt. I did some experimentation, but not so much, but you can find it on Hugging Face, on GitHub.
Yeah, it's the new art of experimenting with prompt engineering. There's one last question that just came up. This is someone mentioning a model name for Chinese document preprocessing. Can we use Entailment Checker with this language?
I don't know, but we should check if there are natural language inference models for Chinese, but I never experiment. But I saw that Julian shared a link about the natural language inference model in Hugging Face. So if you go to that link and then you select a particular language, you can probably find if someone developed such a model. Great.
I think I'll try do my best to any links we've mentioned in this Q&A, I'll try and add them in the YouTube description. So you can find them through there. Hopefully that'll work. And I think we can wrap this up. Thank you everyone for attending our very first project highlight. Just a quick reminder. So we now have a monthly newsletter. So feel free to sign up for that. I think the link was sent in the chat. If not, it's on the website. And also, when we end this, you'll probably be forwarded to a browser page which asks you what you thought about this session. And for anyone who'd be willing to do this sort of presentation, there's also a question for you there. Hope you enjoyed that and hope to see you some other project highlights.
Yeah, thank you very much.
Thank you very much, Stefano. Bye.
Bye.